Now moving to the fourth problem of pyramid. A pentagonal pyramid has an edge of base in the HP. So from this statement, have to start keeping the base entirely in the HP. So I have to start in the first stage drawing the true shape of the base, which is a pentagon below XY line, and inclined at an angle 30 degree to the VP. Means this 30 degree inclination is given for the base edge which is kept in the HP. Okay, but after starting with top view in first stage, then drawing the front view, then in second stage for redrawing the front view, I need the condition with the HP and not with the VP. So this condition 30 degree with the VP will be used in third stage and not in the second stage. Now reading further, while the triangular face containing that edge makes an angle 45 degree with the HP. In previous two problems, the triangular face containing that edge was perpendicular to HP, but here a 45 degree angle is given. So this case will be used for drawing the front view in second stage. And this 30 degree to the VP inclination for that base edge will be used in third stage. So draw the projections of the pyramid when the apex is nearer to the observer. Now this has to be followed, apex is nearer to the observer in third stage. We will discuss when we reach to third stage. The length of side of the base of pyramid is 35 mm and axis is 70 mm. So again we need to start with the pentagonal base in the top view, keeping the one side of the base on the right hand side and perpendicular to the XY line. So starting with the reference line XY, then drawing the one edge of the pentagonal base, so first drawing the perpendicular for marking that base edge. Base edge is given as 35 mm. Then we will mark two angles of 108 for drawing the pentagon. So 108 and 108 on this side also. Be careful while marking the angles. And if you make any mistake in measuring the angles, then after completing the pentagon, you should be able to identify that something is wrong and you should check the angles again. By looking at the pentagon, we can decide whether it is right or wrong. Now, we'll complete the pentagon with base edge of 35 mm. Now we have to just cut the arcs to complete the remaining sides. Okay. So first stage is again similar to the previous two problems. Now here second and third stage will be different. Mostly for three stage, pentagon is asked many times compared to the cone, and that too pentagonal pyramid is asked frequently. Okay, so now we'll give the notations 1, 2, 3, 4, 5. The next step is marking the center. Since the base edge is 34, it will be 17.5 center. Similarly, we need to mark for one more side 17.5. Okay. Join these two sides with opposite corner. to get the center of the base. So here we have located the center of the base, which is nothing but the apex. So we need to join each corner with the apex to draw the slant edges for pyramid. Many of the students forget to draw the slant edges. So we have to remember, when pyramid is there, you need to also draw the slant edges along with the base. In prism, there will be only the base, no slant edges. So after completing, we'll give the notations OO, one for center of the base and one for the apex. Now we'll complete the front view. So for that, first project the axis height in front view, which is given as 70 mm. Okay, and long dash, short dash. Now project the remaining corners up to XY line. 3 and 4 already projected up to XY. Now 2 and 5 will coincide. So 2 and 5 will get one projector, and for 1. Okay. Now we will complete the front view by drawing the boundary arc. 70 mm mark height is marked already. So we will mark the boundary arc. Then base is also dark. First write the notation 3 dash, 4 dash, then 2 dash, 5 dash, 1 dash, then 4 dash and 2 dash. Now this 2 dash, 5 dash is visible to the observer and 4 dash, 5 dash will coincide with it. So after completing the first stage, now in second stage we need to use the condition with the HP, because while redrawing the front view we need the condition with the HP, and while redrawing the top view we need the condition with VP. Now the condition with HP is triangular face containing that edge makes an angle 45 degree to the HP. Now here that edge is 3-4 and base edge which we have kept in the HP, and triangular face containing that base edge is nothing but this edge, which is 4 dash, 3 dash, 4 dash. So we need to make this edge inclined at 45 degree. So we'll rotate this pyramid on right hand side such that this will make an angle of 45 degree with XY. So we'll first fix our point 3 dash, 4 dash here, and with 3 dash and 4 dash we will draw an angle of 45 degree, and on that inclination we will mark that triangular face. Now I'll take length equal to 3 dash, 4 dash, 4 dash at an angle of 45, so that the triangular face will be inclined at 45 degree. Now I'll mark the remaining points 4 dash, 1 dash. So O dash is here, so with that I'll cut an arc for 1 dash, and I'll get one more arc for 1 dash from the base. Okay. So O dash, then 1 dash. Now 3 dash, 4 dash to 1 dash will give me the base, and the other boundary is also dark, and this edge is also dark. Now we'll mark the remaining 2 points, which are 1 dash, sorry, O dash for axis and 2 dash, 5 dash. Okay. So 2 dash, 5 dash and O dash. 2 dash, 5 dash to O dash will be a dark line, and O dash to O dash will be a long dash, short dash. Now we'll complete the corresponding top view by dropping the projectors. In previous two problems, this triangular surface was perpendicular to HP, but here it is given as 45 degrees, so I can show theta as 45 degrees for the triangular surface. So we'll drop the projectors from all the corners. Now we have to draw the projectors from top view also, parallel to XY line. Three dash and finally 4 dash. Be careful while using the roller scale. Should not get tilt while drawing the parallel lines. Now marking the points. So 1, 2 and 5. So this will be 5. For 2 I need to just extend this projector. And this will be 2. Then 3 and 4. So 4 and then this is 3. And for O, this O projector will give me the center of the base and this will give me the apex. Okay. Now first tool is boundary is always dark, so I will make all the edges on the boundary dark. Then O to 2 will be on the boundary because 3 is inside, and similarly O to 5. So after making the boundary dark, now I will select the observer position. For observer above this point, so only O'1' is visible. The entire base is not visible to the observer, but out of that 2 edges are lying on the boundary. So remaining edges I need to mark dotted because it is not visible to the observer. So 4' 5', 4' 3' and 3' 2'. So we have finished all 5 edges of the base. Now we'll move to the slant edges. Out of the slant edges, O'1' is nearer to the observer. So O to 1 I'll mark dark and top view also. Now the remaining 2 edges, 3' to 4', 3 to O and 4 to O. Since 3' 4' is the farthest point for the observer, so all the edges starting from 3' and 4' should be dotted. So out of that, 2 edges are already made dotted. So we need to just mark the remaining edge, which is the slant edge O4 dotted, and also O3 dotted. Okay. So now in next stage we need to redraw this top view, but here the condition is the base edge is inclined at an angle of 30 degree to the VP. Now the base edge is that edge which is kept in the HP. So from first stage the base edge kept in the HP is 3, 4. 3' 4' is a point in front view. Again here it is a point. But now in the top view we are again getting the same base edge and which is having the same true length. Okay. So this inclination is given for true length and we are still getting the true length in second stage. So we have to just tilt this 3, 4 which is the edge kept in inclined at 30 degree to the VP. So if I want to make this edge, so our method is to draw first the rectangle outer boundary enclosing that entire top view. So first if I want to make this edge inclined at 30 degree to the VP, so I should draw first the inclination 30 degree, but if this edge is 30 degree, then obviously this boundary of the rectangle will also be at inclined at 30 degree. Now here, so means we'll start by drawing this boundary of the rectangle inclined at 30 degree, but here while rotating this top view we need to consider one more condition, because it is given that pyramid, that draw the projection of the pyramid when the apex is nearer to the observer. Means when the observer is looking for final front view, its direction will be here. So this apex should be nearer to the observer. So I need to tilt like this. So this will come down and this base will go up. Okay. So I will tilt this edge of the rectangle at a 30-degree inclination and we will redraw this. So first I will draw the angle of 30 degree. And we are not directly marking the edge, base edge 3, 4 first, because 3, 4 is parallel to this outer boundary of the rectangle. So if I make this inclined at 30 degree, so obviously after completing this, we will get this line inclined at 30 degree. So first I'll randomly mark one point here, because nothing will come above that point after tilting. So now we'll mark that length. Okay, on that 30-degree inclination. Now these two edges are other lengths of the rectangle. So for those lines, I need to just drop the perpendiculars. So we'll first complete the rectangle, then we'll redraw the top view inside that rectangle. Okay. Now on this perpendiculars, we'll mark the other lengths of the rectangle. So now we need to take this distance, which will be same as this. So on the both the perpendiculars, so I need to extend those perpendiculars. Okay, so I'll complete that rectangle. Okay, now we can mark other points on that rectangle. So first, for marking 5 from this corner, which is nothing but this corner, I'll take this much distance. Same distance will be used for marking 2 also. Okay, so marking 5 and 2. We are tilting like this, so 5 will go here and 2. Then for marking 1, which is midpoint of the center line of the rectangle, so I'll take this distance. So this will give me 1. And if I draw the line passing through 1 along the length of the rectangle, I will get 2 O points on that. Now for marking for marking this 3 and 4, I'll draw the parallel line to this boundary of the rectangle at a distance from 1. I'll take that distance. Okay, so first I'll draw the parallel line to the boundary of the rectangle passing through 1. And on that line, I'll take the parallel distance from the boundary of the rectangle at which we are going to get that base edge 3, 4. So obviously, as I said before, if this is 30 degree, then obviously if I draw a line parallel at distance mark, so that inclination will be also 30 degree. So here we can mark that parallel line. So this inclination will also be 30 degree. Now to get 3 and 4 from this center point, we can get the distances for marking 3 and 4, which will be same on both the sides. for 3 as well as 4. So with that distance, we'll mark 2 arcs to get 3 and 4. Point nearer to 5 is 4 and point nearer to 2 is 3. So we have marked all the 5 points of the base. Now to mark O, which is the center of the base, I need to take this distance in compass and I'll mark this point as O, and obviously this point is nothing but apex. So now we'll redraw this top view with the same visibility. One to 2, 1 to 5. Then O to 2 is dark, which is the boundary. O to 5 again on the boundary. Then O to 1 is again dark. Axis is already coinciding with O to 1. So no need to show long dash, short dash for axis. Now remaining edges are dotted. So 2 to 3 dotted again. 3 to 4 dotted. 4 to 5. And the remaining 2 slant edges, 4 to 3. And 4 to 4. I think only this is the student find only this part while redrawing the third stage. The rest of the things are easy. We have to just project and mark the points and then join, taking care of visibility. So now after redrawing the top view, we just project from each corner. Don't miss any corner or any apex point or center of the base. And at the end, apex. Okay. Now here we are satisfying that condition that apex should be nearer to the observer. Okay. If it is the given that apex is nearer away from the observer, then we should tilt keeping O nearer to XY line. Okay. So now we'll finish the final view. O dash, 2 dash, 5 dash, then 1 dash, and then O dash. I'll mark all the points. 2 dash, then 3 dash up on the XY line, 1 on this projector, then O, center of the base, will be here, then 4 is 4 dash on the XY line, then 5 on this line, same as that of 2, so 5 dash, then O will be the apex here, O dash. Now again, we'll see the observer position. For observer, first we'll mark the boundary lines dark. So 2 dash, 3 dash will be dark. Then 3 dash, 4 dash will be dark. Now see whether O dash, 4 dash is lying on the boundary. Yes, because 5 is inside, 5 dash is inside. So we can make O dash, 4 dash. Similarly, no, 2 dash, O dash is not on the boundary. 1 dash, O dash is on the boundary. So I'll make that dark. That is the slant edge. Okay. But 1 to 2 is the edge of the base. Again, it is on the boundary. So I'll make it dark. Okay. Now out of the 5 base edges, we have marked 3, 4, 2, 3 and 1, 2 dark. Now remaining 2 edges are 4 to 5 and 5 to 1. But since 5 is the farthest point from the observer, so edges starting from 5 should be initially marked dotted. So from phi dash I am going to get three edges. One is phi dash 4 dash, which is the edge of the base. So it should be marked dotted. Then phi dash to 1 dash, again base edge. And finally phi dash to O dash, which is the slant edge. So it should be again dotted because it is the farthest point, farthest corner from the observer. Now none of these three dotted edges are lying on the boundary, so those are kept dotted only. Now we'll show the apex O dash to O dash by long dash short dash. It should be light line. Okay. Now this completes the solution for this particular problem. But in addition, we can show the dimensions. The base edge is given as 35. Axis height is given as 70. So the angle theta is marked as 45 degree. Now I need to mark this angle. Now this angle is nothing but phi, true inclination in the VP, which is 30 degree. You have to just remember, though this 30 degree with the VP is given first, so it should not be used in the second stage, because inclination with the VP will be used for redrawing the top view and not the front view. Always remember, for redrawing the front view I need condition with the HP, and for redrawing the top view I need condition with the VP. So use the data accordingly. So this completes the solution for this particular problem.